All right, guys, welcome to Talk GCSE by GK Tutoring, and I am going to tackle electrolysis. Now, this is a topic which sounds complicated, but once you learn the rules, it becomes one of the most predictable areas in GCSE chemistry. Now, electrolysis comes up every year in AQA exams, often with tricky wording, unfamiliar compounds, or half equations. But here's the good news. Examiners are not testing your memory. They're testing whether you understand how ions behave. So in this video, I am going to explain step by step and exactly in line with the slides on the screen. So by the end, you will know what electrolysis actually is, how does it break down, what happens to each electrode, the difference between like molten and aqueous electrolysis, and some key topics for higher tier questions as well. So let's begin from the slide here. Now the setup, basically electrolysis is a process of using electricity to break down an ionic compound. So the compound must be ionic, it must be charged particles, and those ions must be free to move. This is why electrolysis only works when a compound is melted, so molten, or dissolved in water, which we call aqueous. Now the setup here should be a direct current power supply, two electrodes, a cathode which is negative and an anode which is positive, and electrolyte. Electrolyte is basically the melted form of our compound which contains ions. Now here's the rule that you must remember. Positive ions go to the negative electrode and negative ions go to the positive electrode. This is because opposites attract. So that rule alone will get you marks in almost every electrolysis questions. Now, going on to the rules at the cathode. Now, the cathode is a negative electrode, and this is where reduction happens, which means gains of electrons. Now, at the cathode, positive ions arrive, they gain electrons, and they turn into atoms or molecules. In an aqueous solution, there is often a competition because aqueous solution means you've added water, which means you've added hydroxide and hydrogen ions, which means that there'll be a little competition between hydrogen ions or metal ions. So the rule that examiners want you to use is that if the metal is more reactive than hydrogen, hydrogen will give up. If the metal is less reactive than hydrogen, the metal will give up and go to the electrode. That's why hydrogen forms so often at the cathode. Most metals are more reactive than hydrogen, so they keep their ground, they stay where they are. Now, when we talk about rules at the anode is a positive electrode, and this is where the oxidation happens, which means the loss of electrons. Now, at the anode, negative ions arrive, they lose electrons, and they form molecules. In an aqueous solution, there's again competition. So, the rule here is if a halide ion is present, like chlorine, bromine, iodide, the halogen will be produced. Now, if no halide ion is present, oxygen is produced from the hydroxide ion, and that's only with the aqueous electrolysis. So that's why in sodium chloride solution, it produces chlorine gas. Sodium sulfate solutions produces oxygen gas because, guys, sulfate, because it's not a halide ion, so oxygen will be produced. This rule is extremely important for exam questions, so keep that in mind. You can pause the video and write your notes down as well. That can help you, okay? Now going on to molten versus aqueous. This is where many students get confused, so let's slow it down. Molten electrolysis is the compound is melted, only the compound ions are present, so there's no competition. So say for example in molten sodium chloride, sodium Na plus goes to the cathode because it's a metal, it's positive. Chlorine is a non-metal, so it's negative ion and it goes to the anode. In terms of aqueous electrolysis, remember we add water to it, and water itself has hydrogen ions and hydroxide ions. Hydrogen ion is H plus, positive ion. Hydroxide ion is OH minus ions. So now there is a competition. That is why aqueous electrolysis is a bit harder, so you must decide which ion is discharged using the rules that I've just covered previously. Now there's certain extra things. If you're doing foundation, you might want to stop here. But higher tier electrolysis, there are certain things that you need to also understand, guys, and you should be able to explain. You need to be confident with half equations, like hydrogen at the cathode will be 2H plus 2E negative with an arrow H2. So you need to learn the half equations. And electrons on the left is reductions, electrons on the right is oxidation. Now, all these rules, see, if you learn the logic, not just the experiments, you can answer any electrolysis questions that comes up in your exam, because they're going to have a metal and a non-metal. So just remember, electrolysis is not shocking once you get the current idea. Okay, and if you find this useful, guys, please don't forget to give me a subscribe. It really helps me and keeps me encouraged to give you more information, make more videos, and help you guys out. Okay, thank you ever so much.